All right. Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to the technical session 4B. My name is Shobhit Pokhriyal, and this session would be moderated by me. On the behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the second World Conference on Information System for Business Management, ISBM 2023, Bangkok, Thailand. The second edition of the conference is being organized in hybrid mode. The physical event is organized in Bangkok, Thailand today, and the virtual event is being held through Zoom today and tomorrow, that is 7th and 8th September 2023. This series is organized in extension to ICT 4SD conference series. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 7 presentations. Please note, in this session, each presenter has been allocated 12 minutes for presentation and questionnaires and answer. It means presenters should finish their presentation in 10 minutes and 2 minutes for questionnaires and answers. On the completion of 8 minutes, rather, I would say, I will raise a gentle reminder so that you can get to know that that you need to adhere with the timings. All right. So there is another request that to all participants to stay connected with us till the last moment, like the closing remarks. Now, if you have any query or update, then you can write it to me in the chat box or Harsh Soni sir in the chat box as well. Before we start the session, I would like to introduce you all to the session of to the chair of the session. That is, first up, we have Dr. Latika Desai. Presently, she is working as an associate professor and head at AI and DS Engineering Department, Dr. D.Y. Patil College of Engineering and Innovation, Viral Campus, Pune, India. She has total 25 years of teaching experience. She has published 33 papers in various journals, her one patent published in Patent Office Journal. She's having 2 copyrights from Government of India. Her area of interest includes digital electronics, data security, and embedded systems, IoT cloud as well. Hello, ma'am. Welcome to the session. Kindly give us with a few welcome remarks, please.
Hello, everyone. You present in the time, okay, as best from your side. Okay, we are waiting for your presentations. Thank you, sir.
Thank you so much, ma'am. Next up we have is Dr. Deepak T. Mane. He is currently working as associate professor at Vishwakarma Institute of Technology, Pune, India. He has 17 years of teaching experience. He has written books on machine learning, fundamentals of programming languages, and principle of programming languages for computer IT students. His main research work focuses on machine learning, deep learning, and supervised clustering. Dear sir, kindly address all of us with welcome remarks. Deepak sir, are you there?
Yes, hello everyone. Yes, am I audible?
Yes, sir, you're audible.
Okay, thank you for nice introduction. Yeah, we can continue now.
Okay, thank you so much, sir. Now to start with the papers. First of all, we have Obrador Baldovino Thalia to present the paper on a perspective of household waste collection methods. Ma'am, are you there in the session?
Good afternoon, everybody. Can I start my presentation?
Can you try in once?
Yeah.
Yeah, please do. Now you'll be able to do it.
Well, my name is Talia Obrador Baldovino. I am research professor at the Universidad de la Costa in Colombia. And below I will share the result obtained in the resource called A Perspective of Households Waste Collection Methods in collaboration with the teacher Gustavo Gatica at the Universidad del Bello in Chile. Different studies have examined various waste management systems with the aim of knowing the benefits and consequences of using, recycling, or despite disposing of waste through landfills or incineration. Within waste management systems, there is a cycle of activities such as collection, transportation, processing, recycling, and waste disposal and monitoring. Of these activities, the most expensive and important is collections due to the intense labor required and the massive use of vehicles. 80% of the waste management system correspond to collections. However, despite the implementation of various collection systems, there are deficiencies in the process, such as low levels of material recovery, uncompetitive system, misuse of resource, negative impact on society, illegal waste disposal, high system fees, cost underestimation, operating costs, overruns, and inadequate decision-making process. In addition, there is still no standard that indicates how an affordable, environmental, protective, and socially acceptable or urban solid waste management system can be developed, which limits advance in the optimization, comparison, and evaluation of the same based on a exhaustive analysis of different case studies and comparisons or different systems knowledge is obtained about the age prior of the implementation of the system. For the implementation of the system, the most important step is to determine whether there is legislation that requires industries to recover their products in the post-consumer state. If there is no legislation, it is important to be clear about the reason that motivate the implementation of a household waste collection system, and based on these reasons, establish the objective of the system. Since there is no legislation that establishes the entity involved, the participants of the system are chosen and the roles further definite through the assignment of responsibilities. In the contrary case, that there is legislation, it is necessary to identify its indicators, that is the recycling percentage established for each material. Then it is necessary to determine the limits of the system, to carry out a demographic study, and to define the billing method of the system. And finally, it is necessary to make it known to the community where it will be implemented. Below is show the components of a household waste collection system. Among these are the method, type of truck, frequency of collection, type of material, for of classification, type of container, and location of the containers. In the type of method, the collection or household waste can be divided into curbside collection and drop-off collection. In the curbside method, each as home must have container for the collection of material. This method can be full service in which the waste collection team requires the bins. Entities then and place them back at their residence and regular curbside pickup where residents are required to place the bins or bag outside the house on the side wall where they are collected and entity and type by the company in share. In the drop-off method, the resident transports the material to a determined place and deposits then in individual containers. The curbside method, it is found that it is the most comfortable method for the user, but represents higher collection fee than in the drop-off method. In the drop-off method, the costs are lower than curbside method collection, but as difficult find suitable sites the containers. So this study can be conclude that there is a lot of information on the state prior to the implementation of a household waste collection system. Information on the system planning process is scarce. A fundamental factor is the participation of the state to decide waste recycling target. It is necessary to know the region where the system will be known through a demographic study. The system must be adjusted to the conditions of the community. Collection is the most important and costly process in a waste management system. Approximately 80% of the cost of a waste management system correspond to collections. So the components of the system must be chosen carefully. Future resource, the household waste collection system could be economically evaluated before its implementation. Thank you so much.
Okay, ma'am, I have one question. Yeah, so you are saying waste management collection system. So can you elaborate some more on what is the novelty in your system, in your model?
Can you repeat me your question?
Yeah, novelty of your proposed model, contribution from your side. What is contribution from your side?
Okay. My study contributes to generate policies for implementation, for mitigation impact ambiental. Yes, Gustavo.
Thank you, Professor, for your question. The principal contribution of this study is take the actual process in ambiguous and contaminated city from Colombia, because in Colombia we have a lot of delivery. For this reason, the volume of the waste is very higher. However, the process related with the REP law, responsibility of producer, not is in this moment implemented in Colombia and at equals in Chile. For this reason, we this study we make and a little comparison between Colombia and Chile. Perhaps this gap not is visible in this presentation. For this reason, in this moment, we're working with a different simulation to quantify the economic contribution with the change, the periodicity, change the different vehicles, and the increment the actors or stakeholders that participate in the process of the recollection of the waste.
Okay, thank you.
The next presentation.
Yes.
Okay, proceed.
One moment, please. Okay. I will share the results obtained in the resource called design of a generic simulation model of direct and reverse logistics of PET plastics focused to mitigation of negative impacts on retailers in collaboration with the teacher Gustavo Gatica and Gonzalo Aguila at the Universidad Andrés Bello in Chile. In recent years, it has incremented PET plastic waste, and there is not an economic incentive strategy to recycle it. Considering that there is currently no legal and environmental framework that to control its disposal, it is generating an informal recycling and leading these waste to be disposed in landfills, thus generating social health problem.
Okay, it's fine. It's fine. Thank you. Thank you.
Different solution alternatives have been proposed, among which are refundable deposit system, which have not been fully accepted, mainly due to the damage caused to merchants due to having the great burden and responsibility within the system. Likewise, other solution alternatives have been presented, which seek to maximize the level of container collection, the improvement of environmental logistics and organizations, the identification of socioeconomic factors in the management of hazardous household waste, the maximization of profits under a voluntary refundable deposit system, the implementation of policies to mitigate negative impacts on retailers under a refundable deposit system, and the cost benefits analysis of refund system, containers deposed, the evaluation of the environmental impact of PET and its low recycling rates, the estimation of a refundable deposit system and its economic feasibility, the possible illegal activities or fraud in the system of refundable deposit of rates, and the factor of the payers that show high sensitivity according to their potential environmental impact, among other investigations. In general, the study carried out point to the design or strategies to reduce the environmental impact caused by post-consumer goods, as well as their optimizations. There is a manufacturer that sells the brigades for different retails, and a recycler who buys the empty container that is recovered by distributors. The producer sells the base rates to the retailers. The retailers sell the base rate to the consumer. The consumer discard the empties to the retailers or returns them to the retailers, and the retailers sell them to the recycle. In the initial scenario, the system includes two types of containers. The manufacturer has its own vehicles for the distribution of beverages. The truck that distributes the drink makes a row in which is edge of the retail facility. If they have placed an order, the vehicle has sufficient capacity to deliver the orders of the 4 retailers in the same trip. The model assumes that each customer requires a single unit of the same product under the proportion equal of the factory's productions. The initial inventory is estimated under the assumption that as retail supplies for a certain number of days. The collection rate for empty container is half of the beverage is sold. Likewise, 5 different alternative scenarios are proposed to determine the most favorable conditions of retail. In scenario 2, the manufacturer increase the order dispatch days. In scenario 3, the retail's reorder point becomes almost half their initial inventory. Therefore, their order quantity is also affected. In scenario 4, the order quantity is greater, as well as the quantity corresponding to the reorder point. In scenario 5, the collection rate of empty containers increase. In scenario 6, the conditions given in scenario 2 and 4 are combined. There is a mere tendency among all retailers to achieve higher valuations score in those scenarios where an increase in the frequency of dispatch by the manufacturer involved, since this reduces shortage considerably, and consequently both direct and reverse flow are impacting possibility benefiting the entire supply chain. Scenario 4, which consists of increasing the order quantity, also proves very positive result, and according to the analysis carried out, it can be determined that it is even more viable for retailers, since the decision to implement it is up only to them. Under this scenario, retailers can safely incur higher storage costs by maintaining higher inventories, since the associated benefit is much greater. In the scenario 1, 2, and 4, it is appreciated the positive impact it causes by the increase in the quantity of their orders. In scenario 5, the recovery rate is higher and the economic benefits on retailers becomes constant. To the study, it can be concluded that this study contributes to establish control mechanisms and public policies policies in the collection of PET containers, the adoption of policies to mitigate negative impacts on returns in rate incentives, the adoption of this type of police grading facilities, the development of logistic factors such as demand, the frequency, dispatch, the number of order and the level of inventories must be specifically considered, which are the ones that generate the greatest impact on the operation of the supply chain. The recovery of empty container is a variable that directly affects the reverse flow of the supply chain, and the fact that they want to invest in this work depends exclusively on the retails. This study can be as a starting point to delve into aspects such as the case in which customer bag more than one container at a time, as well as the case in which customer decides to return containers discarded by other consumers. Thank you so much.
Okay, so you did some study on control policy in PET containers. So can you tell us about the challenges you face? Challenges.
Challenges.
Oh, thank you, Professor. The principal challenge is in the complement of this simulation, because the main problem in this context of the waste and in particular the PET is the education, because the container to put the water, the people don't reduce the space that used in this container. For this reason, only its volume, not its weight. For this reason, not is a good business for the nano recollected in the different point of the city. For this reason, this is a part of this study, because the second part of the complement is the education of the population, and this education is in the parvulary school and the school of the different city, in particular with Colombia, in particular in Chile, because don't have the culture to reduce the trash. It's very we have a lot of the buildings, and the whole people only put your trash without separate the different type of the waste. For this reason, the principal challenge is in this moment is education. However, education with the capacity that the our government to reduce the tax of the tax for incentivize the regulation of the recycled trash.
Okay, thank you.
Can you tell any adoption of policies? Can you explain one? Adoption policies? Adoption policies.
Yes?
Anyone?
One. Oh. Different different places of the city, they, in particular with the retail, are the pilot to separate the trash in this moment. Only this is the policy in the governmental policy, because in the retail is more bigger produced of the recycled waste. For this reason, is more economic impact to the industry of the that use the recycle.
Okay, thank you.
Thank you so much, ma'am and sir,
For
for the
you.
presentation.
See you. Thank you too much for your question.
Thank you so much.
All right. So next up we have is Sanjay V. Hanji, who is going to present his paper on Digital Frontiers, Gen Z's Adventure Tourism in Metaverse. So are you there in the meeting? Sanjay sir? Harsh sir, is he there in the meeting?
No, Shobit, I think so. He's absent.
All right,
You
all
can go
right.
ahead.
Okay, let's move further. Next up we have is Santosh Shivaprakash, who is going to present his paper on heuristic optimization on deep neural network with horse herd optimization for efficient face recognition framework. So are you there in the meeting? Harsh sir, is he absent?
Yes, I think so. He's also absent.
Okay, so let's move further. And now we have the Tihomir Dovra Medvedev, who is going to present his paper on interaction between artificial intelligence, 2D and 3D open source software, and additive technologies for the needs of design practice. So, are you there in the meeting?
Yeah, hello, I'm here.
Okay,
Can
all
you
right.
hear me?
Yes, sir. Yes, sir.
Hmm.
Over to you, sir.
Thank you very much. So I will start my camera.
Yes, sir. Please do.
Yeah.
You may share your screen as well, sir.
Can you see my screen?
Yes, sir. It's visible.
Okay, thank you. So first I would like to represent myself. So I am Associate Professor Tihomir Dovramadje from Technical University of Varna. All the team which you see on the screen are my colleagues from my department of industrial design, same university. So I will represent our science article. And I will starting with general information, with a few words about the abstract. So the modern technologic means are in a period of great development, both in terms of software and additive technologies. They are diverse in terms of functional and technical parameters, which expands the possibility of work and increase the efficiency of designers in their work. There is a transition from Industry 4 to Industry 5, where the interaction between the various systems is increasingly adequate and technically correct. So this research explores the possibilities of correlation between artificial intelligence, AI, two-dimension, three-dimension, open source software, and additive technology for the needs of design practice. Concrete process for creating geometry examples for 2D tracing to 3D digital and the real models are presented in details which have undergone stages of development from conventional computer design with open source software, OSSS. The advantages of the SVG and STO file formats are presented. through which the interaction of different software and additive technologies is upgraded, which increases the quality of the final products in design practice. I will go forward directly with the extended information. You can see the basic lines. So the rapid progress of software and additive technologies significantly transform design practice, bringing about numerous benefits to both people, designers and arts, including industrial engineering and other stakeholders. For industrial engineering, these technological advances have opened up a world of opportunities to optimize and streamline design and manufacturing process using advanced software tools and additive technologies. Engineers and creative highly accurate 3D models, simulate and analyze their design and performance and functionality, and make informed decision before physical production begins. This not only reduces the time of the cost associated with traditional prototyping, but also enables engineering to identify the correct design faults early in the process. As a result, industrial engineers can deliver products with improved quality, efficiency, and reliability, ultimately improving the overall competences of their organization. Similarly, artists have benefited immensely from advances in software and additive technology. These tools provide artists with powerful platforms to unleash their creative and realize their vision. As the shift from Industry 4 to Industry 5 takes place, there is a growing focus of nurturing interaction among various systems that are not only more suitable, but also technical robust. So here you can see the table 1. So we show it the state-of-art open source software and available resources that can all stakeholders, as an example, all of our students use more or less these technical tools in their practice, or they study in our department. So we made a focus in this table. The focus of the article is to find the best way and extended opportunities how all these resources as artificial intelligence, 2D, 3D software can interact in the best way between each other, because the process is very huge. So it's very important personal designer to know how to proceed with this technological means. So I will go with the methods. So technicals for creating the 3D dimension geometric. So as you can see on the slide, there are different methods. So from conventional production of the two-dimension shape from the baseline. So you can use some parametrical models. So directly in Blender software, there are possibilities to use the software for needs of two-dimension project, three-dimension project. Of course, Blender is most popular with three-dimension design. So the most important in this case for us is that exactly this software has a very good interaction with Python, with ChatGPT also recently, because you can use personal ChatGPT, of course, and just generate some scripts, and after this copy paste to environment of Blender. But there are very good free add-ons that you can directly use ChatGPT in the Blender software, so you can paste Python scripts directly in Blender and receive 3D geometry, for example. So this is very important. This is very actual right now from the last 1 year maximum. So these are new opportunities. So of course, there are other tools which I mentioned below. So you can use and other artificial intelligence generator. These tools can help other general open source software, for example, and Krita and GIMP, like very popular raster softwares, and also Inkscape as a lead of the direction of vector graphic software. So this software very good to interact with other softwares. So designers can use SVG files. So this is a very important moment that you can very rapidly design very accuracy with high precision design the final model. So without need of the conventional work. So the idea is how we can reduce the worst part of the work of our designers. So how we can improve their skills with using all of these tools, how we can interact them with these different file formats, how they work each other. I focus these different tools. So here are some important clarifications. So I explained more or less our vision about the process, but in our focus are, of course, SVG, STL file formats. So these are very important of all of these software. So very easy with these softwares. We can, for example, tracing two-dimension image, of course, and make tracing and transfer via scalable vector graphic file format to other softwares, for example, Blender. And after this, we just need to optimize the geometry with convert the objects from curves to mesh, and after this design the final 3D model.
So
if we need to so if we need to produce after the process the model, so STL file format is in the priority. So here is a very visible methodology for creating high quality 3D dimension models for design practice. So this is the same structure you can see by own. So I can, of course, give more details probably after you ask me some questions. I will provide my answers. But this is the main structure. So we can, of course, add in more details, but this is a very huge process, basically. But we try to focus the most state-of-art possibilities. So here we provided a real example of technical implementation. So left on the screen, you can see our university main page. This is English version of main page. The link is provided, of course. So the idea is how we can very quickly, very accuracy to convert the logo of our university, the text of our university. So I mean exactly the font of this text, because this is important to receive exactly the same geometry. So the idea is how we can convert in optimized way two-dimension image to 3D design for our needs. So I'm on the left, just a second. So we use a
Hey, Umesh,
Inkscape
sir.
software.
Sir,
Sorry.
sir, actually, you have exceeded 10 minutes. So kindly conclude this presentation, please, in order to
Okay,
commence.
okay. Just 1 or 2 minutes maximum more. So here visibility, I show what I explain with my words. So after Inkscape, so the ready geometry after tracing is transferred to Blender software. You can see we received already only curves, so the image already disappeared in the back. So after this, as I said, we convert the object from curve to mesh, and we can extrude the baseline to 3D dimension. So about the solid base, so this is the very good possibilities that we can construct via conventional methods. We can use
Sir,
Python
sir,
scripting.
excuse me. Sorry.
Yeah, yeah.
Go to the last slide, please.
Okay. I finish. Okay, so here we use the and more software. So on the right, you can see the final product after all of this process of reproducing with additive technology. So we in this article try to mention the most important moments, most important softwares, and all of these advantages for creating very good quality final 3D models. So here are the results. So I explain it, I will not repeat. In the conclusion, you can read by own. I will not repeat the text. And the research article is apart from the science project which we develop right now with my department colleagues. So all these technologies are included in this science project, and we present right now our work. So thank you very much. Here are references. Thank you. Can you hear me?
Yeah. Okay. So you tried to convert 2D into 3D
Thank you.
by using the Blender. Okay. So can you elaborate more on what is your contribution as a part of research? What you did?
Yeah.
Just you in the Blender, or you are adding something from your side? Contribution of your work.
Yeah, so the idea is from one side to produce exactly this 3D model for our local needs, because this model we will use for advertisement in our local university. And from other part, we use at the moment to combine all of these state-of-art softwares in one science research to represent to stakeholders how they can use most usefully these resources, how this can help to our colleagues in my science field to their work, because you know, this technology, some of they increase very quickly, very much. Some of them they are recently appear on the market or on the internet websites. So we try to join all of this important information in one place. So this is on another hand, that we can share our experience with our colleagues. So we find this for a very important moment. And also, I would like to mention that these softwares, this experience is gained more than 10 years in my department. So of course, this research just focus some important moments, but this research can reproduce many other science articles with more details, with other examples. with providing more and more elements to the process. And I think this is very important that this experience can find a real place to show to public this experience, because basically these softwares, they're somewhere in the virtual environment. People use personally one or other by their choice, but not many people have knowledge how they can pick up all these very strong resources to build their design, optimize it with very high quality geometric with best results. So this is our opinion. So this is our goal of the this science articles. Also for the project, also this will be delivered to our colleagues in my department, so the science article will be used in the next activities.
Okay, thank you. Okay.
Thank you very much.
Is there any limitation of your system?
Is there any limitation, you mean, about which system? About
while design, you are proceed for 2D to 3D, right? So while doing that, any limitations are there?
No, the idea of open source is not to have a limitation. So this is the politics of open source softwares to make unlimited future process that from one side professional can improve the system. From other side, individuals, programmers can join this system by their vision. So this is an amazing process. If you or another colleagues work in the same place and follow this process last years, so our colleagues can mention that the process of creating of open source is really amazing. So, for example, if we pick up a Blender, you can notice that every week probably appear more than 10 new add-ons to this system. So basically, open source software, they are only this is a basement of many other included inside softwares like these add-ons, because less people use only the basic function of these softwares. So people, I mean professional designers and artists usually would like to improve by their own these softwares with other tools with the same idea to improve their final results, to improve mostly 3D geometry, because most important in this science article, of course, is 3D dimension geometric, because artificial intelligence, two-dimension software, for example, like Inkscape, so they just help the process to final producing of a 3D model. So the idea is how all of these tools we combine and provide the final file format to 3D printers or to CNC machines. So this is the most important. So the additive technologies to receive the right 3D data, and you can reproduce the exactly same geometry which we would like to design.
Okay, thank you, Professor Timur.
Thank you very much.
Thank you so much, sir, for this presentation. So next up we have is Mohammad Alif Sheikh, and he'll present his paper on machine learning approach analysis for early stage liver disease prediction in the context of Bangladesh and India. Are you there in the meeting, sir?
Yes, I am there.
Okay, over to you, sir. Kindly share your screen.
First of all, I apologize for the camera as I am presenting from desktop. Unfortunately, there is no camera in my setup.
Oh, that's all right, sir. Just present your paper.
Myself, MD Alif Sheikh. I am honored to be here today to present our research on machine learning approach analysis for early stage liver disease prediction in the context of Bangladesh and India. Here are my co-authors. I would like to take this opportunity to thank the organizers of this conference for providing me with this platform to share our findings. Here is the presentation outline that I will discuss now. Let's start with understanding the importance of liver health. The liver is the largest organ of our body. It does critical jobs like bile generation, blood cleansing, and vitamin storage. Liver diseases are a big global concern, affecting millions and leading to severe conditions like cirrhosis and liver cancer. We are using machine learning to help detect liver disease early, which can save lives. Here are some problems that we have been pointed out here. The problem we are tackling is the late detection of liver disease. Often these diseases aren't spotted early when treatment is most effective. Liver diseases can be tricky to diagnose because they have various symptoms. Also, many healthcare systems don't have enough resources to detect liver disease early, and treatment can be costly. So our goal is to find the machine learning model that can predict liver disease early. We will compare different models using accuracy, precision, recall, F1 score. Early detection means better treatment outcomes for patients. Before we dive into our approach, let's see what others have done. There have been many studies using different algorithms and data sets to predict liver disease with varying levels of success. Now let me explain our approach. We started by collecting patient data from reliable sources. Then we filled in missing data and removed extreme outliers to clean the dataset. We also simplified the data by removing some features. To balance the dataset, we used different techniques like oversampling, undersampling. After preparing the data, we tested it with 8 machine learning algorithms like gradient boosting, random forest, extra tree classifier, KNN, extreme gradient boosting, AdaBoost, LogitBoost, and CatBoost. Also, we employed a voting classifier to combine the results of all of the different models. Here we can see we get the data from two sources. One is the UCI machine learning repository in India and Dhaka Medical College in Bangladesh. These datasets include various medical test results. Now we implement the 8 machine learning algorithm. Here we can see in table 1, exclusory classifier performed the best with 99% accuracy. After that, random forest had the highest accuracy among Canon, XGBoost, and Gradient Boost. As our dataset was imbalanced, to tackle this imbalance issue, we used undersampling, oversampling, and synthetic minority oversampling technique. After undersampling, as we can see in table 2, XGBoost, extra tree, and random forest still perform well with 95% and 94% accuracy respectively. And the gradient boost had the highest recall at 97%. And also the voting classifier did well with the 97% recall too. Uh, uh, in table 3, after oversampling, improved random forest and extra tree, both scoring high on accuracy. But in overall, extra tree topped them all. Also in table 4, after synthetic minority oversampling technique, extra tree, random forest, and cat boost maintain high accuracy, precision, and recall. So taking everything into consideration, the extra tree model has demonstrated strong performance across all aspects. In conclusion, we have shown how different balancing techniques impact machine learning algorithms. Some like XO3 and random forest excel with the balanced data, while others like AdaBoost may need further refinement. Our research provides insights into handling imbalanced dataset in healthcare. Our work shows promise for early liver disease detection, but there is rooms for improvement, more improvement, and exploration of other methods. We hope this helps in creating more reliable tools for liver disease diagnosis. And here are all the reference have been shown that we used for this study. Thank you for listening.
Okay. In this presentation, you tried to predict early liver disease. So when you compare the results with the machine learning techniques, can you tell me why particular algorithm is giving the more accuracy? What are the parameters? From that parameters, you can say these are uh, the new things in that algorithm. So due to these factors, I am producing the better results when I compare the result with the other classifiers. So what are the new things you added in that algorithm as a part of research? Yes, please.
In this research, we want to demonstrate the effectiveness of various machine learning algorithms in liver disease prediction. Our main target is to address the challenges of imbalanced dataset as resampling technique.
But imbalanced data set, okay, it's a part of pre-processing. But when you put the results and when you compare your result with the other classifiers, so why particular classifier is giving the more accuracy? What are the points and what are the challenges and what are the points? These points, this particular classifier is giving the more performance. Can you tell us?
We just use the pre-trained model. We didn't explore in the machine learning more deeply. It's
Okay,
our future target.
okay. Me too.
Mr. Alif, which data
Yes.
sets you are handled here?
Uh, we are using two data set. One is from USI ML repository, which is Indian liver disease, and we are manually collecting dataset from our country from Dhaka Medical College.
How many only means if we are increasing the number of data sets, how much data sets you are handled here?
Uh, we only handle two dataset here.
Yeah, only two. Okay. Thank
Thank you.
All right, sir. Thank you so much for the presentation. So next up we have is Jay Koitsa. She'll be presenting on the topic that is using the OEE score to enable collaborative decision making for human machine interaction in an industry 5.0 setting. Ma'am, are you there in the session?
Yes, good day. I am here.
Oh, so over to you, ma'am. Kindly share your screen.
Yeah, I'll just share my screen. Okay, so you see my screen.
Yes, ma'am, it is visible now.
Thank you. The title of my presentation is Using the OEE score to enable collaborative decision making for human machine interaction in an Industry 5.0 setting. I will be looking, just have a short introduction, then look at the overall equipment effectiveness, the experimental setup that was used, the results and the findings, and then finish off with a conclusion. So Industry 5.0 represents a paradigm shift in which the primary objective is to create intelligent environments that are more focused on the collaboration of humans and machines rather than the need to increase economic benefits brought about by the endless increase in production processes in automated environments. Now, human-machine interaction is crucial to an automated system's effectiveness, but there is currently not a lot of study on the development of collaborative decision-making that takes into account how the human will fit into this environment. This study makes use of the overall equipment effectiveness as a key performance indicator used in manufacturing for the measuring of performance effectiveness of production processes. In the context of this study, the OEE is used to determine which tasks or actions are best performed by a human, a machine, or a collaboration between a human and machine in an Industry 5.0 setting. The paper discusses the research methodology, which is a single case experimental setup, and we are making use of an existing automated water bottling plant as a case study. The discussion of the OEEs, the performance and the results related to the case study will conclude the presentation. So if we first look at the overall equipment effectiveness, human-machine interaction as the center of the research plan for the improvements and development of smart manufacturing has developed to become a focus area of Industry 5.0. The metric of OEE as a key performance indicator was introduced for measuring the equipment productivity in a manufacturing system and has been extensively recognized by companies for implementing lean manufacturing and maintenance programs for measuring the actual performance of equipment. For this study, the OEE, as mentioned, is used for determining and indicating when the human operator should perform a task or an action and when the machine should operate automatically during the production process. It is noteworthy that manufacturing processes with an OEE score above 85% are in highest level. However, we place our test at 90% as the water bottling plant is operating in ideal conditions. The proportion of fully productive time to intended productive time is a method of calculating the OEE. The formula looks as follows. The good count times the ideal cycle time divided by the planned production time equals the overall equipment effectiveness score. The variables that is used in this case study is the good count, is the total number of 330 and 500 ml bottles per customer order. The cycle time is, the ideal cycle time is the average time of producing a 330 ml plus 500 ml bottle per cycle. And then the total or planned production time is equal to the total time to manufacture a customer order. Just a quick overview of the water bottling plant. The plant is to generate bottled water in 330 ml and 500 ml sizes according to customer orders placed via an online web application. Figure 1 shows the setup of the plant, which is split into 3 units and it runs on smart manufacturing units. As you can see, SMU1 is used for filling the water bottles, SMU2 is for capping, and SMU3 is used for packaging of the completed orders. The constraints that will be taken into consideration for the case study is the level of the water in the storage tank, the number of bottles and the number of caps in storage. Here is a picture of the physical setup of the automated water bottling plant that is currently functional. As referred to in the introduction, the study uses a single case experimental study or the case study, whereby a machine-only approach and a human-machine collaboration approach is executed. For the purpose of presenting the importance of OEE, 3 scenarios consisting of random customer orders are taken into account with the results and findings showcased for each scenario. The total time to manufacture is determined by a SAS program that takes the constraints mentioned into consideration. The total time to manufacture for both the automated mode and the human intervention mode is calculated and can thus be compared. As mentioned, this study places the OEE at 90%, which can be seen as a good benchmark for checking the accuracy of the model, and also brings into factor the constraints as mentioned. The 90% OEE score is coded into the SAS program, and the SAS program executes and is able to provide output regarding the effectiveness of the machine. The significance of the OEE is that after executing each customer order, a result of yes or no is generated by the SAS code. The no indicates that the machine should continue without any human intervention. That means the OEE is 90% or above. And the yes indicates that the human should intervene as the OEE starts falling below 90%. The next 3 slides showcases the results of the single case experiment that was executed. In table 1, the total times to manufacture for the automated mode as well as the human intervention mode is shown. It also shows the OEE percentage. And after that, in the last column, you will see should the human intervene, yes or no. In this instance, the machine carries on with the production without any human intervention. And figure 3 shows the results for the total time to manufacture is very similar in scenario 1. Table 2 or scenario 2.
Ma'am?
Yes.
Ma'am, you've taken more than 8.5 minutes, so it's just a gentle reminder to wrap up in 10 minutes, please.
I will be done just now, thank you.
Thank you.
Okay, so table 2 shows the results for scenario 2. The total time to manufacture automated versus the human intervention mode can be seen that there is quite a difference between the total time. The OEE score is also above 90% for the first 2 customer orders. After that, the human starts intervening as the OEE now falls below 90%. The last scenario, table 3, is quite a large order, and it shows that the human intervenes from customer order B. The total time to manufacture for the automated mode is quite high in as opposed to the total time to manufacture for the human intervention mode. So also the human intervenes a lot more in this scenario. Graphically, it can also be seen that the total time to manufacture is much less when the human is working in collaboration with the machine. Now, in conclusion, the aim of the study was to see how the OEE can be used to enable collaborative decision-making for human-machine interaction in an Industry 5.0 setting. Based on the results showcased in this paper, the applying of the OEE to this case study allowed for the enabling of human-machine collaboration, and the results clearly showed that there was an optimization of the manufacturing process of the water bottling plant. Finally, for future work for this research project, we will be trying to see if a protocol for collaborative decision-making in a smart manufacturing environment can be developed. Thank you.
Okay, ma'am. I have one question regarding OEE score. Can you tell me how you calculate the OEE score? Is there any formula?
Yes, because of the time constraints, it was quite difficult to exactly show how it was done. We did it manually, and the water bottling plant, we used the manufacturing line, and the time to fill the 330 ml bottles as opposed to the and the 500 ml bottles, the time was recorded for each size of bottle, and then the average time could also be calculated after we got those results, and that was fed into the formula that I referred to in this slide.
Okay. Okay. Thank you.
Sorry, I have a question. Is it possible?
Yes.
Thank you, Dr. Jenny. So it's very interesting and nice presentation. I would like to ask you about, can you provide some more information about the MATLAB algorithm calculation in the code system? Do you use in this technology stage artificial intelligence? Because you mentioned in your title Industry 5. So I think this is very important to mention. Probably you mentioned somewhere in your science article. I just read the presentation and listen you, because from my understanding of the thing, so the basic ergonomics is human, machine, and environment. So I think as you use the term Industry 5, probably you need to make a little bit more accent to artificial intelligence and the process.
Yes, yeah, this study is not at that stage yet, so I will take that into consideration. Thank you.
Okay, thank you very much. Good work.
Thank you.
Jenny Kochar, ma'am, just I want to ask, with the method of OEE, gold 85%, right? And for your method, it is 90%. How it is? Can you explain?
Why we set the OEE at 90% is because the water bottling plant is functioning in very ideal conditions. So there won't be a lot of breakdowns and interruptions. So we could set it at 90%, which is still in the top level.
Okay, thank you. Your area is demanding. Thank you. Topic is demanding. Thank you.
Thank you so much.
Thank you so much, ma'am, for the presentation.
Yeah.
All right. Now I would like to call few names who missed out the presentation, and if they're present, kindly pop up. Now, Sanjay V. Hanji, sir, are you here? and Santosh Shivaprakash, sir. Are you both in this session or shall we proceed?
Go ahead, Shobhit. I think so. They will not join.
All right, sir. Got it. Well, I sincerely thank our authors for their excellent presentation in this session and all the participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during this second version and the previous first version of the conference. We will be happy to have you again in the third version in 2024. All the presenters will be getting their digital certificates through email within 2 working days. Further, all papers have already been forwarded to Springer. The publication will be live within 6 months, so kindly cooperate with the team of ISBM 2023. And afterwards, I would like to thank our session chair, Dr. Latika Desai, and Dr. Deepak T. Mane for chairing the session. So, few words do you like to give us as a closing remark?
Yes, sir. First, I would like to say for the Global Knowledge Research Foundation, thank you, Aman sir, Amit sir, and Richa, as well as Shobit sir and Harsh sir too, for inviting me in this ISBM as a technical session chair. All the present, all authors presented their paper very nicely on the demanding topics. One submission from my side, those topics they are taking, just have to see what are other researchers had did till a date, and they compare their results. So they can enhance their research with some better prospects. Okay. Thank you all. Thank you.
Thank you so much, ma'am.
And thank you, Deepak sir, too. Thank you.
Okay, first of all, thank you organizing committee, Amit sir, Richa ma'am, and all coordinators for giving us to work as a session chair for this wonderful conference. All presentations are good, and yeah, definitely we will do the same work in future. Okay, thank you.
Thank you so much, sir. Thank you so much, ma'am. And as a token of appreciation, I would like to share something. Well, this is a token of appreciation. This is for Professor Latika Desai, ma'am.
Thank you, sir. Thank you.
And this one is for Professor Deepak Mane, sir. Thank you so much for your presence, for your valuable presence, I must say.
Thank you.
And before we move towards the end, can everyone turn on their camera and let's have a quick snapshot of this virtual conference. So everyone who is present here, kindly turn on your camera, please. All right. Thank you so much, everyone. Thank you so much for your valuable presence, and stay safe, stay healthy. Have a great day ahead.